we will discuss about generation of carbocations. So the first method through which a carbocation can be generated is through heterolytic fission of neutral species. Let us consider a molecule in which there is Ry and Y is the leaving group. In such case, what can happen is that this molecule can undergo heterolytic fission to give you a carbocation plus your leaving group as your leaving group Y minus. Okay, for example, if you have your Me3CBr, this is a neutral species which can undergo heterolytic fission to form you your trimethyl tertiary carbocation and your bromide ion. Okay, similarly, if you have a benzyl chloride, then this benzyl chloride can give you your benzyl cation plus your chloride ion. Also, if you have, then in this case also it can form you your corresponding carbocation plus your chloride ion. In the third case, you see the stabilization of this carbocation is because of the heteroatom oxygen, which can give its lone pair of electrons to stabilize this carbocation. So these are some of the process by which your carbocations can be produced via heterolytic fission. Also, if you have a silver positive, okay, then this silver can catalyze, okay, and shift reactions from SN2 to SN1, which results in the formation of carbocations. For example, if you have silver plus, okay, and then if you have an alkyl bromide, in such case what can happen is that because silver has a very high affinity for halides, it will form silver bromide plus you will get your carbocation. So whenever there is this type of silver to catalyze the reaction, it always shifts the reaction from SN2 reaction to SN1 reaction. Ionization may also be induced by Lewis acids. So for example, if you have this type of organic compound, and when this is reacted with BF3, what happens is that this can result in the formation of a acyl cation, okay, and BF4 minus. Right, since BF3 is a Lewis acid, hence it can pick up the fluoride ion and then it can form the acyl cation. This is your acyl cation. Okay, in this case the equilibrium lies towards the right because of the exceptional stability of the tetrafluoroborate anion. Okay, because of the exceptional stability of this tetrafluoroborate anion, because of this reason what happens is that the equilibrium lies towards the right. Also, if you have Me3Cl, this can also react with aluminium trichloride to give you negative. Okay, this type of species. Now this one, what can happen is that can undergo decarboxylation. Understand? Can undergo decarboxylation to give you the more stable tertiary carbocation along with your loss of carbon monoxide plus AlCl4 negative. So even this type of Lewis acids such as aluminum trichloride can also form you the more stable tertiary carbocations. So this can Lewis acid can also help in the generation of carbocations. Another example for the generation of carbocations is when alkyl fluorides are reacted in the presence of Lewis acid antimony pentafluoride in sulfur dioxide as solvent. In such case, what happens is that if you have alkyl fluoride where R equals to alkyl group, okay, and then you have your Lewis acid, that is your antimony pentafluoride, then you carry out the reaction in sulfur dioxide. What will happen is that it will generate the carbocation plus SbF6 minus. So this is also how a carbocation can be generated. The other method for the generation of carbocation is via addition of cations to neutral species. Addition of cations to neutral species. For example, acid catalyzed hydration of alkene. Okay, basically this is a protonation reaction. Now supposing you have a alkene where you have C, and let's say that you have this type of alkene, okay, where let's say these are your R groups. Now if this alkene is okay reacted with an acid, what can happen is this pi bond can attack this proton, and what it will result is in the generation of a carbocation. So this is how your carbocation can be achieved. Once this carbocation is formed, what can happen is that next it can react with water. Now the water contains lone pair of electrons, so it can attack the carbocation, and then what it will give you is OH2 positive, okay, CH R R R. This is also an equilibrium reaction. Now this one, what can it do is it can undergo loss of a proton to give you your final product, that is this. Okay, so this is how your this one carbocation can be generated via addition of cations to neutral species. Now what happens is that protonation can also occur on oxygen atom in a carbon oxygen double bond. For example, if you have a ketone, okay, now you know that the ketone carbon is positively charged, this is oxygen is del negatively charged. So in this case, if you have H plus, then what can happen is that it can generate this type of ion, which can finally neutralize this like this to give you OH and a positively charged carbocation. So this is how a carbocation can also be generated. Also, example, if you have an acetone, and then you react this with sulfuric acid, then what it will give is a carbocation plus HSO4 minus. Carbocations can also be formed by the acid catalyzed elimination of water or ammonia from alcohols and primary amines. For this, let us take one example, PH3COH. When this is reacted in the presence of sulfuric acid, what happens is that it produces this species in which OH2 positive is a very good leaving group. So now this can leave like this in the presence of H2SO4 to give you PH3C positive, that is triphenyl methyl cation, plus you will have your H3O plus 2HSO4 minus. So this is how a carbocation can be generated by the acid catalyzed elimination of water. Similarly, if you have a primary amine, for example, if you have RNH2, now this one, when it is acid catalyzed, can be converted into NH3 positive. Now this can leave like this to look like this to get a carbocation plus ammonia molecule. So these are some ways how your carbocation can be produced by acid catalyzed elimination of water molecule and also your amine molecule, from primary amines. The last important way for forming a carbocation is from other cations. So carbocations can also be generated via the decomposition of other cations, and the best example is for the diazonium salt. For example, if you have an amine, in the presence of NaNO2 in HCl, can generate you your diazonium salt, diazonium chloride salt. This is your diazonium salt. This diazonium salt can then undergo loss of your nitrogen to give you R plus, which is your carbocation, plus N2 gas. So this is how a carbocation can also be generated from the decomposition of other cations. One of the best example is, let's say you have a benzyl amine. Then this benzyl amine, when reacted with NaNO2 HCl 0 to 5 degrees centigrade, what it will give you is your diazonium salt N2 plus Cl minus. This diazonium salt will then decompose to give you your benzyl cation. So you can see that how from other cations such as your benzene diazonium cation, you are actually leading to the benzyl cation. So these are the various methods how you can generate carbocations. So thank you everyone for your attention. If you like this video, please like and share and also subscribe. Thank you.